Good morning, all. Am I audible to you?
Good morning.
Good
Yes,
morning,
sir.
sir.
Yes, sir.
Yes,
Good
sir.
Yes, sir.
morning, sir.
Yes, sir.
Okay, thank you. See, in the previous class, we were solving numerical examples on perpendicular components, right? So today, we are going to solve some more examples on perpendicular components, oblique components, as well as parallel components. So you must be ready with the notebook, pen and a calculator. So today we have to do a lot of calculations. Okay? Are you able to see the screen?
Yes, sir.
Yes,
Please
sir.
note down example. Determine x and y components of each of the forces shown in figure. See, the figure is shown on blackboard. So you have to find out x and y components of each of the forces shown. So there are three forces. I am saying this is 620 Newton as force P, 480 as Q, and 170 as R. We know that whenever a force is to be resolved into xy components, you must know the angle made by the force either with respect to x-axis or y-axis. So first let us find out from the given dimensions the direction of each and every force. Say the direction of force P, that is 620 Newton with respect to x-axis. I will call it as direction of Q, that is 480 Newton with respect to x-axis, say beta. And the direction of R, that is 170 Newton with respect to x, I am saying gamma. So from these given dimensions, you can find out alpha, beta, and gamma. Now this 500. So now you have alpha is equal to tan inverse. See here, see this right angle triangle. So tan alpha is equal to opposite side, that is 120 upon adjacent side, that is 500. So alpha is
So
equal to
please
tan
write a
inverse.
little bit large.
Okay. So it is 120 upon 500. Similarly, beta is equal to tan inverse. Opposite side is 150, adjacent side is 100. So it is 150 upon 100. And gamma is tan inverse. Opposite side is 50, adjacent side is 700. So it is 50 upon 700. Do the calculations and find out the angles alpha, beta, and gamma. Now you can easily find out the x and y components. For force P, what is the x component? P is making an angle alpha with respect to x-axis. So x component is positive. See the directions. X is positive, y is positive. So Px is equal to P cos alpha. P is 620 cos 13.5. Then Py vertical component P sin alpha, that is 620 sin 13.5. Now you have components of Q. Qx. Q is acting in second quadrant. So you will find the x component is towards left, y component is upwards. And Q is making an angle beta with respect to x. So it is minus Q cos beta. Y minus, it is acting towards left. So it is minus Q sin beta. So it is 480 sin 56.31. Rx. This. See, let's go on this. Now R is making an angle gamma with respect to x, but R is in third quadrant. You have x towards right, y component downwards. So it is R cos gamma. 170 cos 4.08. And the vertical component, that is y component of R, it is minus R sin gamma. So minus 170 sin 4.08. The body on the incline is subjected to horizontal and vertical forces as shown. Find the components of each of the force along and perpendicular to the incline. The block is kept on an inclined plane, having slope 3 vertical, 4 horizontal. F is acting horizontally towards right and P is acting vertically downwards. Now we have to resolve this F and P into components along the plane and perpendicular to the plane. So I am considering x-axis along the plane and y-axis perpendicular to the plane. So simply we have to resolve F and P into Px, Py, Fx and Fy, right? Say the slope of the inclined plane is alpha. Then immediately we can write alpha is equal to tan inverse opposite by adjacent 3/4. How much? 36.87. Okay. Now say here x-axis is along the plane. So we know that the angle made by the plane with horizontal is alpha. So the angle made by F with the plane will be alpha, alternate angles, right? X-axis is parallel to the plane. Then the x-axis is making alpha with horizontal. F is horizontal. So the angle made by F with respect to the x-axis is alpha. Then we can have x component Fx. It is along the plane but acting upwards, and Fy, it is acting perpendicularly downwards. So the component adjacent to the angle Fx is equal to F cos alpha, 400 cos 36.87. Fy, it is as per the direction which we have mentioned here. Fy is downwards. So I will write minus F sin alpha minus 400 sin 36.87. Fx is nothing but component of F along the plane. Fy is the component of F perpendicular to the plane. Similarly, this is the x-axis along the plane, y-axis perpendicular to it. Now tell me what is the angle made by P with respect to y-axis? See here, we know this angle as alpha. So it is 90 degrees, P is acting vertically. So the angle made by P with respect to x-axis will be 90 minus alpha. Therefore, the angle made by P with respect to this perpendicular is alpha. Okay? Now the component adjacent to the angle is cos. Now this is Py and the other component is Px. See the sense of the force. It is acting downwards. So you have Py, it is downwards, and Px towards left. Now tell me what is Px? Px will be minus P sin alpha. Are you getting me? The component adjacent to the angle is cos. Other perpendicular component is sin. Here alpha is the angle made by P with respect to y-axis. So y component is cos, x component is sin. So it is minus 1200 sin 36.87. And Py, again it is minus, acting downwards, P cos alpha. So minus 1200 cos 36.87. If you have doubt, you can ask me. So what are the answers now? Fx 320 Newton, Fy it is minus 240, Px minus 720, Py minus 960. So here minus plus 320, that means it is acting towards right along the plane. So here 240 Newton is acting along the plane but towards left. 720 Px, it is acting along the plane towards left. Py 960 Newton, it is acting perpendicular to the plane but downwards. Fy perpendicular to the plane downwards. Here example 3. A force of magnitude P is acting at point A on the rod as shown in figure. If the vertical component of force is 850 Newton, determine the magnitude of the force and its horizontal component. So here P is making an angle 40 degrees with respect to the rod and acting at point A. So what you have to find out? What you have to find out and what is given? It is given that the vertical component is 850 Newton, right? And you have to find out the magnitude of force P and its horizontal component. So I am taking this as horizontal and a vertical direction. So the component along the horizontal axis and calling it as PH, which is acting towards left. And the vertical component is Py, which is acting downwards. So with here, PH is making an angle 40. P is making an angle 40 with PH. So PH is equal to cos 40 and PB is sin 40. So the vertical component of force is P sin 40 is equal to 850 given. It is given PV is equal to 850. From this you can calculate the magnitude of force P. And the horizontal component P is 1322. Point 36. So pH is equal to 1322.36 cos 40. That is 1013 Newton. It's very important example. In figure, the x component of P is 850 Newton. Determine the magnitude of force P and its y component. See here, the slope of x-axis is 1 by 2 and the slope of y-axis is 2 by 1. That means x and y-axis are perpendicular to each other. Here, the slope of force P is 3 by 4. Let the angle made by x-axis with horizontal is alpha. The angle made by force P with horizontal is beta. Right? See here, this total angle means angle made by P with horizontal. We are having it as beta. The angle made by x-axis with horizontal is alpha. Now to resolve this force P into x and y components, I must know the angle made by P either with respect to x-axis or with respect to y. So let us consider the angle made by P with respect to x-axis as theta. Now can you tell me theta in terms of alpha and beta? Theta is equal to this total angle beta minus alpha. Right? Now we can find out alpha as tan inverse 1 by 2. Angle beta tan inverse 4 by 3. Opposite by adjacent. So alpha is 26.56 and beta is 53.13. Therefore, theta is equal to 53.13 minus 26.56. That is 26.57. So it is angle made by P with respect to x-axis. Now you can have this x component of P, say Px, y component is Py. P is making an angle theta with respect to x. So Px is equal to P cos theta. But it is given Px is equal to 850 Newton is equal to P cos 26.57. That gives you magnitude of force P. And the vertical component Py, P sin theta. P is 950.37. So it is 950.37 sin 26.57. So the y component of P is 425.1. Please do the calculations. Simply do not copy the answers. Oblique So write down the statement. Resolve 60 Newton force, 60 Newton force shown in figure along U and V axis, along U and V axis. Refer figure.
Sir, can you repeat the question?
Resolve 60 Newton force, 60 Newton force into the components along U and V axis. U and V axis shown in figure. So here it is, horizontal axis is U and the axis along this rod is V. 60 Newton is making at an angle 120 degrees with respect to positive U axis. Now you have to resolve the 60 Newton force into two components. One along the axis U and second one is along the axis V. Remember, while resolving a force into two components, you have to see that force is lying between those two components. So this is our force 60 Newton. It is to be resolved along U and V axis. That means the component of 60 Newton along U is towards left and the component along V axis is downwards. Are you getting my point? This is our given force. So the given force must be between the two components. You cannot take that the component of 60 Newton along U axis is like this and the component along V axis is like this. But the given force must be between the two components and the sense of the force and the sense of the components must be same. So these 2 points you have to remember. So as per our sign convention or whatever the formulas you have seen for non-perpendicular or oblique components, can you recall the formulas?
Yes, sir.
Yes, what is the F1 is equal to?
F sin beta
Right.
upon sin alpha plus beta.
Sin alpha plus beta. F2 is equal to?
F sin alpha upon sin alpha plus beta.
F sin alpha upon sin alpha plus beta. Now here F is the given force, alpha and beta. What is alpha? The angle made by the force with respect to F1, right? Beta is the angle made by F with respect to F2. Suppose if I take the 60 Newton as F and the component along U, I am calling it as F1. The component along V is F2. Now what is alpha? It is the angle between F and F1. Beta is angle between F and F2. These notations are very important. Now from the geometry you can find out alpha and beta. So we have this angle as 40 degrees, right? The angle made by V with respect to U is 40. So beta is equal to this total 120 minus 40, 80 degrees. And the alpha is total 180 minus 120, right? This total 180 minus 120, that is alpha, 60 degrees. So F1 is equal to 60 sin 80 upon sin 60 plus 80. Similarly, F2 60 sin 60 upon sin alpha plus beta, that is 140, 60 plus 80. This is nothing but component along U axis, and F2 is the component along B axis. These formulas you have to remember. Along with the notations, that is alpha, beta, F1, F2. So this is 91.92, 80.84. Good. So we will see in the next class.